Thank you. I'm Jian from SK Telecom from South Korea. And today I'd like to give a talk about the AI storage virtualization and optimization for GPU as a service. That's what we are trying to do recently. And first of all, I think you are not quite familiar what is SK Telecom, so I'd like to give a brief introduction to the SK Telecom. So SK Telecom is a mobile network operator in South Korea, and we made the most of the market penetrations in South Korea. And recently, we are trying to transform from the MNO to the AI company. Those are the AI R&D as well as the services that we are currently focusing on. And since our organizations are mostly focused on the AI infrastructure, so today I want to more talk about the AI infrastructure and how TDA can empower us to build up the other AI infrastructure and to provide the GPU as a services. So inside the AI infrastructure, we have about 3 areas. So first of all is AI data center, and we are trying to expand the global data center through the differentiated energy solution and the AI hosting businesses. And their AI hosting business mostly focusing on the GPU as a service for now. And we are also focusing on the AI chipset, and Sapsium with another AI semiconductor companies has been merged with the everybody, and they launched the Atom, another types of NPU, and it's called as next generation AI chip. And the last one was it's a Meta airline that we also have our own ADA-X airline services and the big model, large language model, and that can backed by the other ADA services. We also launch our other ADA service local. So then let me briefly talk about what is a GPU. So I think you are quite familiar with what is a GPU as a service. So GPU as a service is quite similar to the infrastructure as a service, but the main difference is GPU as a service are more focusing on renting the GPUs to the tenants. So if you look into the AI infrastructure for selling the GPU as a service, the topology looks a bit more complex compared to the traditional one. As you can see, there are many interconnects between the GPUs, internally as well as externally. And we also have a storage fabric. Fabric. And in order to provide the no dependency for GPU as a service, we somehow want to virtualize the entire AI infrastructure. And how to provide such a virtualization, we somehow need to virtualize the entire GPU node, right? And typically we are using the HGX or TGX to construct the AI infrastructure, but virtualize the entire GPU node is a little bit tricky. And also we somehow need to virtualize all the interconnects between the GPUs. For example, in the link, also require virtualization, and also the RDNA-based InfiniBand as well as WebKey those are all GPU fabrics are all required to be virtualized, and also the storage fabric as well. So in order to do that, we actually built our own cloud solution called the Petasus AI Cloud, and this is more focusing on providing the GPU as a service for where the emphasis is on high performance as well as the cost efficiency. And as you can see, the Petasus AI Cloud is based on the Kubernetes as a base platform, and on top of that, we built up our own solutions to make it possible to provide the heterogeneous services such as a virtual machine and the containers as well as the Kubernetes. So the users can run their own pipeline as a service on top of our managed Kubernetes as well. And on top of that, the user can run their own service, etc. And we support multi-vendor GPUs, including the NVIDIA, Intel, and the AMD, and also we support some third-party NPUs. So those are all support the virtualizations and so on. And recently we received one award from the global award for the GSNA as a best cloud solutions. So when it comes with the AI storage, we try to find the latest difference between the AI storage and the traditional storage, and we found that AI storage is required in order to do 3 phases. One is for data pre-processing. It requires intensive data analyzation and deduplication, and it requires high performance AI storage. And second is for training, there are lots of intermediate data has been populated. And also we need to periodically do some checkpointing in order to mitigate uh, the, um, the issues at the CPU failures. And the last one is inference. So we can leverage the AI storage to further enhance the inference accelerations by caching by store all the KB caches in the AI storage, so that can further improve our inference performance as well. So actually, AI storage someone need to co-op with the high-speed fabrics like RDNA, and we define the four requirements for the AI storage in order to provide our GPUaaS service. The first one is the storage supply need to be optimized, and someone need to provide a high performance AI infrastructure. And for sure, DDN's high performance, the NVMe and the parallel file system can meet those requirements. And the second requirement is someone need to accelerate error loading and inference through the GTS, GPU Direct Storage feature. And definitely DTS support that. And the third is someone need to be scalable, a plus and scalable AI storage architecture, and the DDN it's support horizontal scaling, as well as it support Kubernetes integrations and so on. So it also meet our requirements for sure. And the fourth is some of the storage sample to be enterprise grade reliability, as well as proven to AI support. Definitely support. So we decided to run some collaboration POCs with DDN. And with those are our collaboration POC scope. One is the solution integration. So somehow we need to integrate our AI platform with the DDN. And there are several ways to integrate that, and we more focus on two parts. One is the integration based on the Kubernetes API. Second is merge tenancy support integration. And based on this integration, we ran some performance evaluations and to see even in a virtualized environment how DDS storage can perform. And the final way is the GPU virtualization support. This POC has not been yet done, but I will give a brief ideas for that later on. So what are the entire deployment topology which has been set up in DDN in Japan? And we have three nodes. One is for control plane with four GPU nodes, and the underneath DDN XR scalar, and we integrate that with using the four networks. And the storage network has been constructed using the InfiniBand switch. It which provided 200 gigabit per sec for a setup. And we run both VM and the containers on this environments. And those are the performance evaluations that are so we integrate the DDN with the Petasus AI Cloud with two methods. The first one is based on CSI driver-based integration. And in this mode, we use a PVC. So we use a PVC we use Kubernetes to generate the PVC, which has been backed by the DDN. And we create one disk image inside the PVC and mount that into the VM and run the test. And the second is a pure RDNA-based test, and it's run the native cluster protocols to do the I/O and so on. So this is the result. So actually, the initial result looks pretty good. And as you can see, even with the virtualized InfiniBand environments, the overall read performance shows quite promising. So we achieved almost 98.4% peak performance for read. For write, we achieved around 94.4% peak performance, which is pretty good for us. Yeah, at least even in a virtualized environment. And even if we run that in bare metal, it shows a more or less similar performance. So the performance degradation due to the virtualization is sort of negligible in this case. For the blob I/O, since it has to go through several layers, we actually thought that the performance even worse, but still we achieved around 75% performance compared to the native cluster. And actually, this is not for daily training or inference. So I think this can be used for storing the real images and the root disk as well. So yeah, so I will just summarize my talk. So So in this talk, as he virtualize the AI infrastructure, the key is to realize the GPU as a service, and the Petasus AI cloud can act as an enabling technology for the GPUaaS, and optimizing the virtualized AI storage is critical for delivering high performance AI services. And for POC collaboration, actually we combine the DDX scaler with the Petasus AI cloud, and we shown quite promising actually result. But still, we have many work to do. So we think it'd be good to have another POC with a DDN to integrate Infinia into the Petasus AI cloud a little later. And we also encountered many issues on such integration. One was the multi-tenancy support, but you can do that manually for now, but it'd be good to have some REST API backup so that we can make an automatic way to support multi-tenancy. And it'd be good to see that DDN can support TrueVirt, which is another virtualization add-ons for Kubernetes. And we also want to do more performance evaluations in terms of the GPU I/O and the GDS. And the virtualization support for the GDS for most of the AI storage has not been done yet. So it still requires more R&Ds in this area. So we think we need to investigate possibility of using the NLink C2C to bypass I/O and NE and so on. So this is the end of my talk, and thank you for your attention.